Hello, welcome to 4.6 isosceles and equilateral triangles. So we're going to review the parts of an isosceles triangle. We've already talked about this. The two sides that are congruent are going to be called legs. The angles opposite of those will be congruent as well, and those angles are going to be called base angles. In between the base angles, that side is called the base, and the angle in between, the angle in between the legs is going to be called the vertex angle. So the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those, called the base angles, are also going to be congruent. And the converse would be switching if P then Q to if Q then P. So if the two angles of a triangle are congruent, then the sides opposite those angles are going to be congruent, and those sides are called the legs. So for example here, if we know these two sides are congruent, opposite angles are congruent. So those will be the same measure. So we can call each of those x. So to find the measure of x, you can either do 48 plus 2x equals 180, or I just do 180 minus 48. That's going to give you 132. So these two added together, 132. If they are congruent angles, they both have to have the same measure. So we can divide by 2, and we will get 66 degrees for each of those angles. So here, if these two angles are congruent, we know they're congruent because they both have one arc in it. The opposite sides, or the legs, are going to be congruent. So we can say 2x plus 4 is equal to 3x minus 10. Subtract an x from both, 2x from both sides, add 10 to both sides, and x will equal 14. If you plug a 14 in here, this is going to be 32, and this is going to be 32. So double check. Just like here, you should have said 66 plus 66 plus 48. On to the back side. Example 2, we can also have variables. If you have variables, we want to solve for the value of each variable. Well, these two sides are congruent, so I would solve for y first. It does not matter. They're independent of each other, but we can have 4y minus 2 is equal to 2y plus 2. Therefore, we get 2y equals 4, y equals 2. Plug them in. 8 minus 2 is 6. 4 plus 2 is also 6, so y is in fact 2. If this is 80 degrees and these two are congruent, their opposite angles are also congruent. So 180 is the sum of all three. 180 minus 80 is 100, so these two added together will be 100. If they're congruent, they both have to be the same, so they both have to be 50. So this has to equal 50 degrees. So 6x plus 8 will equal 50. When we solve that, we're going to get x equals 7. So there's both of the variables. Theorems for equilateral triangles. A triangle is equilateral if and only if it is equiangular. We've talked about that word before. Equiangular means all three angles are congruent. And we've also talked about in an equilateral triangle, each of those has to measure 60 degrees. So if we look here, all of these have one arc, which means they're all congruent. They're all 60 degrees. They're all 60 degrees. It's an equilateral triangle, meaning these two have to be congruent. So we can set 5y minus 6 equal to 4y plus 12. We will get y equals 18. It's always a good idea to plug it in. You'll get 84 here and 84 there. So we are good. For this one, it tells us all the sides are congruent. If all the sides are congruent, all the angles are congruent. Therefore, all the angles are each 60 degrees. So we get 2x plus 32 equals 60. So 2x equals 28 and x equals 14. If you plug that in there, you will get 60 degrees, and we are done.